in this learning unit, we are going to learn how can we form carbon-carbon bonds using reactions of organometallic compounds. So Grignard reagent is one of the most useful organometallic compounds. So however, the use of Grignard reagent will give you some advantage and also disadvantage. So the first advantage is by using Grignard reagent, it is a very nice way to make new carbon-carbon bond, and it can be made easily from simple alkyl or aryl halides in magnesium in dry ether solvent. Note that you must use dry ether solvent. However, the disadvantage of using Grignard reagent is they are rapidly decomposed by oxygen and water. So this is related to the word dry here. And then it is also a good base, and it can abstract acidic proton if you are using amine, alcohol, water, and etc. So Grignard reagents, they are normally prepared by the reaction of organic halides with magnesium turnings, and usually when we do a Grignard reaction, we use ether solvent, because when we use ether solvent, it can form a complex with the Grignard reagent, which subsequently will stabilize it. So this is how we can prepare a Grignard reagent from a normal alkyl halide. So we react in the magnesium. We react with magnesium turning in diethyl ether to give RMGX here, and we can also use aryl halide reacted with magnesium turning in ether solvent to give us a Grignard reagent made of aryl halides. So this is the specific reaction where we can use. So the first one involves the use of iodomethane. So this iodomethane is reacted with magnesium turning, and we use ether solvent at mild condition of temperature, which is only at 35 degrees Celsius. So it can afford methyl magnesium iodide, which can be obtained at 95% yield, which is quite high for a reaction. Instead of using alkyl, we can also use aryl halides as shown in the second reaction. So how do Grignard reagent works with carbonyl compounds? So the most important mechanism of this reaction involve nucleophilic addition mechanism. So in this case, when we have alkyl halide here, we react with a ketone. In this case, it is a ketone. So we use two conditions here. The first one, we use solvent ether, and the second step, we add some acids to it. So it will give us tertiary alcohol plus magnesium halide. So how is the mechanism? Okay, when we have Grignard reagent, when we add the solvent ether, what will happen? The solvent ether will stabilize the Grignard reagent, and then it will give us a nucleophilic nucleophile and electrophile. So what happens is when we have this nucleophile of R-, it will attack the carbon of the carbonyl compound, because this carbon is partially positive carbon because it is attached to the oxygen, which is an electron withdrawing group. So what happens when this nucleophile attack the partially positive carbon? So the electron of the pi bond will now shift to the oxygen, and it will result in a halo magnesium alkoxide. So at step 2, when we add acid, what will happen is that the oxygen in the alkoxide will abstract the proton of the acid, and then this electron will move to the oxygen, and it will result in a tertiary alcohol, water, and magnesium halide. So carbonyl groups can undergo nucleophilic addition as mentioned in the previous slides. So what happened is that the nucleophile adds to the partially positive carbon, and then the pi electron shifted to the oxygen, and the carbon becomes sp hybridized and therefore becomes a tetrahedral compound. So carbonyl group and alcohol, it can only be interconverted using oxidation and reduction reaction. So if you have a primary alcohol, when it undergo oxidation, it will give you an aldehyde, but if it undergo reduction reaction, it will give you a primary alcohol. When we talk about Grignard reagents, so there are few conditions where the use of starting material will give you different types of alcohol. So in this slide, we've seen two examples here. The first example here, when we use aldehyde as our starting material, when we react with Grignard reagent, it will give us a secondary alcohol. If you look at the aldehyde, it has R group, while the Grignard reagent has R double prime group. So in our final product, we will have one R group and one R double prime group, which means this alcohol is a secondary alcohol. So in the next example, when we use ketone as the starting material, so what we will get is a tertiary alcohol. So if you look at the tertiary alcohol here, the structure contains R group from the ketone, R prime group from the ketone, and also R double prime from Grignard reagent. And we always know that Grignard reagent contain a nucleophile, which is the carbanion R-, which can undergo nucleophilic addition mechanism under basic condition, and the reaction is irreversible. What does it mean by irreversible? This means that if we have aldehyde or ketone, if we use Grignard reagent to transform it into an alcohol, we can no longer produce aldehyde or ketone unless we oxidize the alcohol using another reagent. There is also a condition where a Grignard reagent cannot be prepared from the compounds. So in the first example here, if we use this group of compound, so the Grignard reagent can react with these groups because this group has mostly contain oxygen and nitrogen. And then a Grignard reagent, at the second example here, if you look, that a Grignard reagent can be easily protonated by this group. So in case when we want to choose a solvent for Grignard reaction, we cannot use solvents that contain this functional group because it is easily protonated.